For this example, looking at exponential models from Year 2 statistics, we have rabbits introduced onto an island. Data was collected on the number of rabbits, which is n, t years after they were first introduced. This data is shown in the table below, and then we have the table. Then goes on to say the data was coded using y equals log n and x equals t. There is a regression line of y on x that was found to be y equals 1.903 plus 0.0867x. Given that data can be modelled by an equation of the form n equals kb to the power of t, part A, find the values of constants k and b. Okay, so first thing to consider is that our data's been coded and it no longer, in this equation that we need the form here, this equation doesn't have y or x, so we need some way of substituting in both n and t. Okay. So the first step is to look to see, right, well, what does y equal? Y equals log n. So on this part here, we can just replace y with log n. We can then look at the next bit. We've got 1.903. Well, nothing is going to happen to that at the moment. And then we have plus 0.0867x. Well, we've been told that x equals t. So we can substitute t in for x. So we now have taken all the y and x parts out, and we've managed to substitute n parts and t parts. We now need to look to see, right, okay, well, we've got log n. When log's written on its own, that is log base 10. So we can raise both sides as a power of 10, which means on this side you will just be left with n, because 10 to the power of log n, the log would cancel out. And on the right hand side, we raise everything as a power of 10. Now let's do a little bit of work with this right hand side. I've got 10 and I've got two powers added together, which means I can then rewrite as two separate powers of 10, but multiply. And using your calculator, calculate what 10 to the power of 1.903 is, and round that to three significant figures. I would have 80.0, and that is multiplied, and then here we can do 10 to the power of 0.0867, and again, three significant figures. That will give me 1.22 to the power of t. So let's look back at the question. We need to find constants k and b. So we need n equals kb to the t. So we can write, therefore, k equals 80.0 and b equals 1.22, both rounded to three significant figures. Right, part B. Give an interpretation of the value of k found in A. So k, we've got 80.0. We want to have a look at our equation here, and we think, right, t, and if we look at the beginning of the question, t is the years after they were first introduced. So let's see what happens when we let t equal 0, so the initial part of the data collection. So when t equals 0, n is going to be 80 times 1.22 to the power of 0, which of course will just be 80. So that means 80 would be the initial population of rabbits. Okay, part C. Estimate the number of rabbits on the island after 8 years. Comment on the reliability of this prediction. So there's two things to do there. One is a straightforward plug some numbers into the calculator. So using our formula for n, we've got 80 times 1.22 to the power of 8. That's 392.6. Which again, we'll round to the nearest rabbit. That's 393. We're asked then to comment on the reliability of the prediction. Well, we need to look to see whether 8 years would comfortably fit within the years already observed. And as you see from our table, the years observed was between 1 and 11, so 8 would be within that range of data. So we can conclude this is reliable since 8 is within the years observed. Finally, part D, find the number of years after which the number of rabbits first exceeds 1,000. So now we've been given what n is, so we've got 1,000, and that equals 80.0 times 1.22 to the power of t. And we need to work out what t is. So we can use our calculator to do this for us. We enter in the equation as we see it. So I've got 1,000, and then we need to get an equals sign. So that is alpha, and you can see the equals sign there, so that's equals. Then we put in 80.0 multiplied by 1.22. Now we're not going to use t, we will use x on this calculator as our variable. So to get x, we've got this little button here, but we need to make sure that it is a power, so x. Now we want the calculator to actually solve this for us. So if we press shift, and we press where it just says the yellow solve, we press there. Initially it will come up with x equals 0, that's because we haven't actually told it to do anything yet. So we press the equals button, and it will give us a solution of 12.7. Okay? So we can say t equals 12.7. Look back at the question to see whether we need to round up or down. Sometimes we would have to truncate. But this one, it says the number of years after which number of rabbits first exceeds 1,000. So we can say, therefore, 13 years.